Hello, Professor. We are Gotel, and our topic is 超越 air pollution prediction model. Our team members are 蔡耀宇、蔡武浩 and 洪明进. Next, these are our outline. Next, first we will introduce the knowledge area. And next, today we will discuss air pollution with a focus on 超越. Air pollution refers to the presence of harmful substances in the air, impacting both health and the environment. These pollutants include particulate matter, nitrogen oxide, sulfur dioxide, ozone, and carbon monoxide. Each of these pollutants can cause serious health and environmental issues, which we will explore further in this presentation. Okay, next. In 超越, air pollution primarily comes from four main sources. First, industrial emission. 超越 is a major industrial area with many factories and power plants emitting pollutants into the air. For example, there are many electronics and petrochemical factories in the area, which release pollutants such as sulfur dioxide and nitrogen oxide. The petrochemical industry in particular is known for high emission that contributes significantly to air pollution. Second, vehicle emission. The high volume of traffic in 超越, including cars, bus, and motorcycle, contributing significantly to air pollution. Major highways like National Freeway No. 1 and No. 2, which pass through 超越, add to the traffic-related air quality issue. 3. Construction dust. With 超越 repeat urban development, dust from construction sites and roadworks also worsen the air quality. Lastly, natural factors such as local climate conditions like wind and rain patterns can influence pollution levels by either dispersing or concentrating pollutants. For example, the northeast monsoon can sometimes help disperse pollutants, but on other days with little wind, pollutants tend to accumulate, leading to poor air quality. Next, addressing air pollution is essential due to its health impacts. Clean air reduces the risk of respiratory and cardiovascular disease, enhance public health, and lower medical costs. Environmentally, population damage ecosystem, causing issues like rain, and also contributing to climate change. Reducing air pollution helps combat less serious environmental challenges. Okay, next. Air pollution also has economic impact. Health problems related to pollution increase healthcare costs and reduce productivity. Address this issue promotes sustainable development by encouraging green technologies investments, fostering long-term economic growth. Socially, raising awareness inspires eco-friendly lifestyle and supports policies that protect the environment.
Research background. Why is air pollution worth researching? Air pollution has powerful links to the economy, whether it is from personal productivity or from the negative impact on environmental pollution. It raises health caused by pollution, source caused by industrial and commercial activity. In a report by an Organization of Economic Cooperation and Development, it is clearly stated that by 2060, the additional medical expenses incurred by humans due to air pollution will be 2 to 2.5 times higher than the medical expenses in 2020. And a figure on the impact of air pollution on the economy. Energy and Clean Air released a report that air pollution caused global economic loss of US $2.9 trillion in 2018, or 3.3% of GDP that year. These losses are caused by us humans using our health in the pursuit of economic growth and the impact of health damage on business operations. Let's jot down economic data. Building high-precision forecasting models. Modern air quality forecasting models are mostly based on machine learning and deep learning algorithms. However, air pollution data is highly nonlinear and unstable, and it is influenced by multiple external factors. Accurately modeling the specific pollution patterns for different regions and the season remains a challenge. An example of an early warning system. China's air quality forecast and warning system has a factory intervened in weather alerts for heavy pollution. For instance, during the 2022 Beijing Winter Olympic, the air quality warning system successfully helped local authorities take measures in advance, such as reducing factory emissions and traffic flow, which keep air pollution at a low level during the event. Research motivation and purpose. Research motivation. Air pollution harms human health and requires huge medical expenses, which in turn creates an economic burden. Predict a change in advance and establish an air pollution prediction system for the future in real time. Let the public no longer only pay attention to the current air quality, but can make adjustments to future conditions and reduce future medical expenses. Purpose: improve accuracy, hoping to make a prediction model with an accuracy of 80% to 90%.
Next, let's go over the methods and tools we plan to use for our project. Starting with data preprocessing and cleaning, we plan to use Python, Pandas, and NumPy libraries. The advantages here is their high flexibility. Pandas helps with data manipulation and NumPy supports numerical calculations. Next is exploratory data analysis. For this, we plan to use Python's matplotlib and Seaborn libraries. This tool allows us to create customized plots and perform statistical analysis, and we can use them directly within Jupyter Notebooks, which makes it easier to create and share our reports. Next, for model evaluation and optimization, we'll be using Python scikit-learn and Jupyter Notebooks. The advantage of scikit-learn is that it's easy to integrate cross-validation, which helps provide a reliable estimate of model accuracy and makes it easier to fine-tune the model. And Jupyter Notebooks can provide interactive environments, visualize results, and adjust parameters. Next, I'll introduce the supervised learning algorithms we plan to use. The first is random forest. These algorithms reduce overfitting by combining random sampling with multiple trees, making it more resistant to noise. It's also great for datasets with many features and is not sensitive to missing data. Additionally, random forests can rank feature importance, which is helpful for further feature engineering. However, it also has its disadvantage. It requires significant memory and computing power to build multiple trees, and it might not capture complex nonlinear relationships in the data as well as gradient boosting. And the second method is gradient boosting. It effectively reduces bias. making it suitable for applications that require precise predictions. Gradient boosting is also highly flexible, allow us to select different loss functions and control model fit by adjusting learning rate and tree depends. Even with smaller datasets, it performs well. However, training with gradient boosting is time-consuming due to its interactive nature. Additionally, if the number of trees or the learning rate is too high, the model may overfitting, so careful tuning is required. Parameter adjustment such as learning rate and tree depends are also more complex. This is our proposal, and here are our references. Thank you for your listening.